So in this video, we're going to look at graphs of trigonometric functions again and transformations of trigonometric functions. So let's see what we're asked to graph today. Okay, so today we're asked to graph y equals 3 cos of 1/2 x minus 1. Okay, all right, so again, let's start with the graph of our parent function or our basic function, which in this case is y equals cos x. So let's start with a graph of that. All right, so we'll just do one period because that's all we need to really see what's going on. So what's the period of cos x? The period of cos x is 2 pi. So let's take that 2 pi interval and divide it up into 4 equal intervals. Right, so we pi over 2 pi, 3 pi over 2, and 2 pi, and of course we start at 0. Our amplitude for cosine is 1. And let's put in the points, our main point. So cos of 0 is 1, cos of pi over 2 is 0, cos of pi is -1, cos of 3 pi over 2 is 0, and cos of 2 pi is back to 1. And then let's join everything with a nice smooth curve. And this is our cosine function, graph of our cosine function for one period. So now if we look at our function that we're given, y equals 3 cos 1/2 of x minus 1, let's take a look at what transformations are being performed here. So our 3, this 3 gives us a vertical stretch of 3 units. The 1/2 being multiplied to x gives us a horizontal stretch of a factor of 2. And the -1 out here is a vertical translation down 1 unit. So what do we have? So I think I misread this 3. This 3 is a vertical stretch of a factor of 3. The 1/2 is a horizontal stretch of a factor of 2, and the -1 is a vertical translation down 1 unit. Okay. So let's consider this vertical. Well, first, actually, let's take the 1/2 and figure out what it does to the period. So since we're stretching things horizontally by a factor of 2, this is also going to change our period of our new trigonometric function by also a factor of 2. So let's see how it does that. So our new period is our old period divided by that value 1/2, and this just gives us 4 pi. So our new period is 4 pi. Okay, so let's use this and draw out a new set of axes. I'm not sure if that's going to be the. All right, let's try it this way. Okay, so that might be better. And we're going to take that 4 pi. We're going to divide it up into 4 equal intervals. So we have 0 pi, 2 pi, 3 pi, and 4 pi. Okay, so now let's go back up. This negative, so we've taken care of the 1/2 times x, that factor of 1/2. Now the -1, that's a translation down 1 unit. So if we notice in our original graph of our cosine function, our axes about which our graph oscillates is the line y equals 0. So that line is going to be translated down 1 unit to y equals -1. So let's do that. So let's put that here. Let's say that's -1, and let's just use a dotted line. All right, let's mark off a few points here. 1, -2. Let's try this. Okay. Okay, so we're getting theirs. All right, so this dotted line is our axis. So our new graph is going to oscillate about this new axis. Now, if we go back up to our given function, the 3 is a vertical stretch of a factor of 3. So that means our amplitude is now 3. So our new amplitude, we can write that in. Our amplitude is 3. So this means wherever in the original curve or the basic curve of y equals cos x, we have a 1. We're going to end up with an amplitude of 3, or 3 units away from our axis. So our axis is now at -1. So when x equals 0, our new value is going to be 2. Then at pi, we're going to have a value of -1. At 2 pi, the value of the function is going to be -4, so 3 units down from -1, because our amplitude is 3. At 3 pi, we're back to our axis, so y equals -1. And then when x equals 4 pi, our amplitude again is 3, so we're back at our maximum value of 2. So if we let's join these dots with a nice smooth curve. So this is the graph of y equals 3 cosine of 1/2 x minus 1. Good. That brings us to the end of our session today. If you have any questions, feel free to send us an email at info@raisemymarks.com or give us a call, day or evening, and we look forward to hearing from you. Thank you for watching.